Bats are social animals. They roost in large groups, and when they emerge from their cave, they experience severe acoustic interference. If you stand next to these kind of caves, it's really impressive to see the bats, to hear the noise that they emit. And when a bat wants to perceive its environment, it emits an echolocation call and wait for the reflected echo in order to perceive its environment. When another bat echolocates at the same time, it can jam the reflected echo and the bat will experience a missing of information. This missing of information can lead to collision, and that can be fatal in many cases. And we know that bats can deal with this kind of severe acoustic interference because we can see that most of them can fly and maneuver, and the risk of collision is actually low. And we wanted to understand how they do that, how they deal with this severe acoustic interference. In order to answer this question, we used miniature tracking devices to look at the movement of the bats and also at their echolocation. And we also used very comprehensive sensory motor model to answer this question. What we found is that the moment that the bats emerge from their caves, they change their behavior and also their echolocation. They increase their distance from the center of the group, but still maintain the group cohesion for many kilometers. And they also change the characteristic of their echolocation in order to get higher resolution of information. And the result is a decline in the jamming proportions that they experience. And they do that really quickly, within seconds. And that allows them to avoid collisions. For many years, we were trying to understand this situation. And now we have the technological capabilities to track individual bats to understand how they perceive their environment. And that allows us the ability to answer this question of how they deal with this acoustic information. And again, it's provided us a new perspective about how bats can perceive their environment.